Hi everyone, welcome to part 1 of Unit 7, Trigonometry. This corresponds to Chapter 7 in your textbook, so if you ever need a reference, you can go to Chapter 7. Right now, I'm going to do the guided notes Day 1 that correspond to Worksheet A, and the next video will be on Worksheet B. So Worksheet A is about special right triangles and corresponds to page 4 in your notes packet. I'm going to skip around a little bit. Each year I teach this in a variety of a different order, and so right now I'm going to start with the unit on special right triangles, or the section on special right triangles. So I'm on page 4 and I'm going to be going on to page 5. So for right now, I'd like you to focus on the lower right-hand corner of page 4, special right triangles. I'd like you to take note of these two special right triangles that we have here, the 30, 60, 90 right triangle, 30, 60, 90 right triangle, and then I'd like you to look at and remember from geometry or algebra 2 that one thing that makes a 30, 60, 90 degree triangle special is the ratio of the sides are always constant. So the side opposite 30, the x, is going to be the shortest. The side opposite 60, the x square root of 3 is the middle length, and the side opposite the 90, 2x, is always the longest. So those relationships, those ratios, always hold in every 30, 60, 90 triangle, no matter what the shortest leg, longest leg, or hypotenuse is. All right, so let's get started. And the same, back up for a second, the same is true for the 45, 45, 90. It's even simpler because the opposite angle, the corresponding side to these opposite angles are the same. So you're going to have two legs that are the same and a hypotenuse that is in the ratio of x square roots of 2. All right, so now let's put some numbers to this. Going on to page 5 now. I've got a 30, 60, 90 triangle that's in a ratio of, that has length side 12, leg side B, and hypotenuse A. So if I apply those ratios, which is x, 2x, and x square roots of 3, what I'm going to do is set 12 equal to x square roots of 3 and then be able to solve for x. So if I know that x square roots of 3 equals 12, I need to solve for x by dividing both sides by the square root of 3. Now, it's not enough to just say x equals 12 over the square root of 3. I need to rationalize that denominator, which means multiply by square root of 3 on both the top and the bottom. So then x is going to be equal to 12 square roots of 3 over, well, square root of 3 times the square root of 3 just simplifies to 3. Now I can cancel the 12 and the 3 to 4 square roots of 3. So x is equal to 4 square roots of 3. So that means that side B opposite 30 is equal to 4 square roots of 3. Side A, well, that's 2 times 4 square roots of 3, so that's equal to 8 square roots of 3. And the side opposite 60 is equal to 12. So I've found all three sides of this special right triangle, 30, 60, 90. Now, moving on to the second one. Let's do that one in a different color, maybe in red. Okay, now the triangle's oriented differently, but that doesn't matter. It's now, you could think of it as a 60, 30, 90 triangle. But still, the side opposite the hypotenuse is going to be 2x. The side opposite 30 is going to be x. And the side opposite the 60 is going to be x square roots of 3. So again, I'm going to set 18 equal to x square roots of 3. Divide both sides by the square root of 3. And what I get is that x is equal to 18 over the square root of 3. But I have to rationalize that. I can't have a square root in the denominator. So I multiply the top and the bottom by the square root of 3, and I get that x is equal to 18 square roots of 3 over 3. Those cancel, so I get that x is equal to 6 square roots of 3. Well, there's side B, 6 square roots of 3 over here. The hypotenuse then is going to be 2 times 6 square roots of 3, so that's going to be 12 square roots of 3. And, of course, this side is 18. Okay, now moving on to the 45, 45, 90 triangle. Well, I can call this x, I can call this leg x, and I can call the hypotenuse 2x. Nice and simple here. If x is equal to 24, sorry, if 2x is equal to 24, then I know that x is equal to 12. So that means that leg A is 12, leg B is 12. It's that simple. Now, the hypotenuse, 20, in the next example, equals 2x. Divide both sides by 2. X equals 10. And so the length of each of those legs is 10. And there you have it, a review of the algebra and geometry, algebra 2 and geometry lessons behind the math that corresponds to the finding the leg length of special right triangles.